go. Hello and welcome back to Calculus 1 section 3.10 on derivatives of inverse trig functions. So for this particular section, we're going to see 6 formulas for inverse trig for the derivatives. And you will see that they are very similar between the groups of, between the pairs. We'll see how that works. And some of these formulas, namely inverse sine and inverse tangent, will show, and you will be expected to know them in Calc 2 differential equations, and rarely in Calc 3, but might be there as well. I mean, we can work it out. The derivation for these is outlined in the book. If you're interested, you can stop by office hours if you need clarification on any of the steps. Since it's not an honors section, I'm just going to give you the formula, and then we're going to compute a couple of examples. So we'll start with all 6 written on a pile. So the derivative of sine inverse of x is going to be 1 over square root of 1 minus x squared. So that's an important one. Even more important is the tangent inverse of x, which is 1 over 1 plus x squared. And then the derivative of secant inverse of x, which would be 1 over absolute value of x square root of x squared minus 1. So these are the basic 3. And now, the really cool thing is that the other 3 are the same, they just have minus signs. So the derivative of cosine inverse of x is minus 1 over square root of minus x squared. So it's really cool that if you know inverse sine, you know immediately inverse cosine. Just put them negative. And the same goes for all the other ones. So cotangent will just have a negative 1. Cotangent inverse of x is negative 1 over 1 plus x squared. And finally, the derivative of the cosecant inverse of x is negative 1 over absolute x square root of x squared minus 1. So these are your 6 inverse. And as I mentioned, the most you guys will be using, right, is inverse sine and inverse tangent. The other ones do show up on exams here and there. But crucial for your future education, right, especially Calc 2, Calc 3, you absolutely must know inverse tangent and inverse sine. Now, these formulas, the way they're written, which is the same way they're written in the book, you see that they're all inverse sine of x, inverse cosine of x, inverse tangent of x. But generally, we don't have that. We have inverse sine of f of x, inverse tangent of f of x, because that will give us chain rule. Later on, will give us the u substitution for integration. So we want to focus on the formulas that have not sine inverse of x, but sine inverse of f of x. And in which way would that impact the answer on the other side? So now let's go with purple. The derivative of sine inverse of f of x. And that one is going to be f prime of x divided by the square root of 1 minus f of x squared. So I need you to see that they have the same form. Every x is replaced with f of x, and because of the chain rule, it has to be multiplied by the derivative of f of x. So this is the modified formula that actually has a as a function in there, and the one for the tangent is also very useful. And I mean, you can transform all 6 of them, obviously. These are the 2 that are used the most. So f prime of x divided by 1 plus f of x squared. I'll put these on the cloud because they are used a lot. But obviously all 6 should get their version of f of x. And now you just take some derivatives. Keep in mind f of x can be anything, and you need to be able to take the derivative of that f of x for f prime for the chain. So let's say you have the derivative of tangent inverse of e to the 3x. Try to follow the formula to answer this on your own. Okay, so what do we have? Well, first in denominator, we have 1 plus, and now f of x is e to the 3x, so e to the 6x, right? Because e to the 3x squared is going to be 3x times 2, which is 6x. And now the derivative of e to the 3x is 3e to the 3x. And that's it. That's all it is. That's all it is. Let's take a look at the derivative of tangent inverse of x of, what should I put there? I don't know, x squared plus 1, whatever. And hopefully it will be the same deal. 1 plus, we have x squared plus 1, and that needs to be squared, and then the derivative of x squared plus 1 is 2x goes up. The derivative of cosecant inverse of x over x squared plus 1. Let's see. That should be sufficiently annoying to deal with. All right, so the formula that we have to use here has to have f of x everywhere instead of x. So it needs to be f prime divided by absolute f of x times the square root of f of x squared minus 1. And our f of x in this case is x over x squared plus 1. So as we do this problem, we don't have to worry too much. I mean, we do have to worry about chain rule, but we don't have to worry about chain rule everywhere. We worry about the chain rule only in the numerator. So in the denominator, we have absolute x over x squared plus 1 because that's just absolute value of f of x. Then we have our square root. We have to f of x squared. So that's going to be x over x squared plus 1 squared minus 1. So these are literally Control-C, Control-V, right? And now I have to worry about quotient rule because I'm going to multiply this. So I'm going to take the quotient rule in the numerator. So I have x squared plus 1 squared, and then I have x squared plus 1 times the derivative on the top is 1 minus x, and then derivative is 2x. There we go. So really messy, and now just a little bit more algebra. Try and clear it up as much as we can. I still have this x squared plus 1 everything squared, and then over there I have x squared plus 1 minus 2x squared, and then we have x over x squared plus 1 square root of x over x squared plus 1 squared minus 1. All right, so now the numerator simplifies into 1 minus. So I just need to, you know what, a faster way for me to do this is to copy the whole thing and then just fix the numerator. So I'm just going to move this here. Copy this. Put that there. And fix the top. There we go. So that's 1 minus x squared. Now, I'm going to multiply by x squared plus 1 squared to get rid of the double fraction. So that's going to give me, when they cancel, just 1 minus x squared in the numerator. In the denominator, one of these, because I have two of them, right? It's x squared plus 1 squared. So one of them, I'll signify that with the blue, would cancel this one. And the other one will go under the square root. So over here I just have absolute x. And now under the square root, I will have x squared plus 1 squared times the old square root, which is x over x squared plus 1 all squared minus 1. And now I hope you see that now these guys cancel, but it still multiplies to the second one. So 1 minus x squared divided by absolute x, square root of. So when they cancel, you only have x squared left, right? And then minus 1 times x squared plus 1 squared. Now, the squares are not going to cancel here with the square root because this is not a perfect square. I mean, you can make it and force it into a perfect square, but it's not. So we can try and simplify, but I don't think we're gonna get. Let's try. We have x squared minus, and now when I FOIL this, I get x to the 4th plus 2x squared plus 1. So that's when I apply that square. And now I have like terms of negative 2x squared and x squared, so I can put those together, but I don't think they will result in anything cool. I have a negative, so that's going to be negative x to the 4th minus x squared minus 1. So as you can see, they don't amount to anything. You can't factor that, you can't do anything. So that's the end of the road. Now, if this was in chapter 4 and you set equal to 0, then the whole denominator just goes away and your answers are plus minus 1. But right now we're just supposed to find the derivative. So as you can see, we plug everything in the formula. We had to modify the formula from x into f of x, and then just follow some of this mess calculation. This is just 90%, 95% algebra, a little bit of calculus, so not a big deal. Ta-da! That's it. Bye.